This question is taken from the ENGAA 2020 Section 2 paper, and it is question 12. So we read, a 4 kiloohm fixed resistor is connected in series with a light-dependent resistor, LDR, across a 100 volt power supply. The current in the LDR is 5 milliamps. Then the intensity of light on the LDR decreases and voltage across the fixed resistor changes by 50%. What is the change in resistance of the LDR? So we want to calculate the change in resistance of the LDR, and we're given its current, given the voltage supply, and then the value of the fixed resistor, the resistance of the fixed resistor. So it might be a good idea to work with what we know for the fixed resistor in order to get some values and some relationships in terms of the resistance of the LDR. So we know the initial voltage of the fixed resistor is 20 volts because the 5 milliamps times 4 kiloohms. Why is this useful? Well, we're given information that it changes by 50% later, so this might be a good connection to have. What else do we know from the information? Well, the intensity of light on the LDR decreases, and from what we know about light-dependent resistors, their resistance increases as the intensity would fall. So, as the intensity goes down, resistance of the LDR increases. Okay, so what does this mean? Well, it means then that the voltage of the fixed resistor would go down by 50%. So V fixed is now 10 volts. But again, why is this useful? Why do we need to know all this if we're just trying to work out the change resistance of the LDR? Well, using the information on the voltage of the fixed resistor, if you have learnt in school that the proportion of the voltage you take is the fraction of resistance that you have. So if a resistor has resistance R1 and another is R2, then the fraction it takes is R1 over R1 plus R2 of the voltage. So this is why it's useful to know the voltage of the fixed resistor, because we can know these fractions in terms of the whole circuit voltage. So we have 4 divided by 4 plus the initial resistance of the LDR. This will be equal to the 20 over 100, the fraction of the voltage that it takes. So if you solve this quite simply, we get our LDR is 16 kilo ohms. And then how can we get the new resistance of the LDR? Well, now we know that the voltage of the fixed resistor will be 10 volts, so we can use 4 over 4 plus R LDR. The new one in this case is 10 over 100. So this means it's 10%, so we could say the 4 plus R LDR will then be 40, so R LDR is 36 kilo ohms. So then we can easily get the change in the resistance of the LDR as 20 kilo ohms. So this question was quite strange in that we needed to use the information from the fixed resistor's voltage in order to get information about the change in resistance of the LDR. So quite a common trick to use in these when they give you the information about another component is to use a fraction of the voltage it takes, so R1 over R1 plus R2, and that involves the resistance of both components. So that's why it's useful to know the voltage of the fixed resistor.